Hello students, today we are going to see what is a projectile motion or the motion which happens in a plane. So in the first chapter we have discussed about motion in a straight line. Motion in a straight line means only x will vary or y will vary. Okay, either horizontal motion or vertical motion we have considered. Now motion in a plane means there will be change in x-axis also, there will be change in y-axis also. Now the difference is, suppose if we consider this kind of motion, okay, we can say this is horizontal motion. Horizontal motion. Okay, a car is moving in this direction, horizontal motion. Suppose if we throw a ball in vertical direction just like this, we can say this is vertical motion. But suppose if someone kicked a ball, football, and it went like this, or suppose someone hits a 6, okay, 6 projectile motion. Anyway, if you throw a ball, okay, projectile motion, or if someone just like this, something is coming, and if it is going like this, this is also another kind of projectile motion. So in all these places we can say that x-axis is also changing, y-axis is also changing. Okay, x-axis is also changing, y-axis is also changing. Circular motion, x is also changing, y is also changing. Okay, so while handling this motion in a plane, or we can say that motion in two dimension, while dealing this, vector algebra will help us a lot. Okay, so that is the reason after studying motion in straight line or motion in one dimension, we have spent some time in vector algebra. So from here onwards, vector algebra is very much essential in physics. So that is the reason we have studied vector algebra. So here also vectors will come. So in motion in a plane, there will be change in x direction also, there will be change in y direction also. Okay, now we need to understand an important approach while we deal with this topic. Okay, what we do is, see, already we have studied motion in straight line or motion in one dimension. We know how to handle their problems, how to handle the situations if it is straight line. Okay, if you are not thorough about straight line motion, you will carry that difficulty here also. So that is why I am suggesting you, if you have any problem in motion in one dimension, definitely you must watch those videos, correct it, make the fundamentals ready, then come here. Or anywhere if you have any doubt, go and watch that particular topic video at least in motion in straight line, because all those things we are going to apply here. Okay, so I was telling about the approach, what approach we are going to do in order to deal this topic. I told you motion in one dimension means either x or y. Motion in two dimension means x as well as y will come. So what we do is, motion in a plane or motion in two dimension we will consider as two one-dimensional motions. We will resolve this vector into x direction and y direction. We will calculate the x direction vectors separately. We will calculate y direction quantities separately. After that we will just what we do, we will take the resultant. Okay, that is the approach. So in the first class, just I will do a quick recap of motion in one dimension, then the very essential vector basic which we are going to do today. So all these things quickly I will recap, then we will get into the topic. So please remember, motion in 2 dimension, again and again I am telling, please don't forget it. Motion in 2 dimension, if you do this approach, it is dead easy. Very complex questions also we will feel like, oh, okay, I can solve this within no time. Okay, please understand, we will deal motion in 2 dimension as separate 2 1 dimensions. Okay, we will just solve the things like one side it is horizontal, that we will consider just 1 dimensional horizontal motion, just like our motion in straight line. Vertical motion, another one will be horizontal, one will be vertical. Vertical motion we will deal this separately. Okay, that is the approach we are going to do. Okay. Okay, so generally motion we have divided into constant velocity motion. Constant velocity motion, that is, constant velocity motion means throughout the journey it has only one velocity or one speed. If something starts moving with 3 meters per second, throughout the motion it will be moving with 3 meters per second. Okay, so constant velocity means the formula which we are going to use is velocity is equal to displacement by time, or speed is equal to distance by time. Only one formula. If we need to find displacement, v into t. If we need to find velocity, s by t. If we need time, t is equal to s by v. That's it, nothing else. Another thing is variable velocity. Variable velocity. Velocity will be changing, but velocity will be changing at a constant level, just like from 2 to 3, 3 to 4, 4 to 5 likewise, or otherwise 0 to 2, 2 to 4, 4 to 6, or otherwise 0 to 3, 3 to 6, 6 to 9 likewise, constant increase. That means here this is going to be constant acceleration. Constant acceleration. Okay, so here if it is constant acceleration means we will have a particular value of a. So here we will be using which equations? V is equal to u plus at, v square is equal to u square plus 2as, s is equal to ut plus half at square, Sn is equal to u plus a into n minus half. These 4 equations. Okay, remaining all the things I don't discuss because already we have studied. If you have still doubts, then this is really, it is troubling, then you should go and watch the first lesson, first chapter. It should be pakka. Okay, then we should come here. So variable velocity, constant acceleration. So if it is variable velocity, need not be constant acceleration always. Velocity can be from 1 to 10, 10 to 5, 10 to 3. Likewise, it can have many values. 1, 5, velocity was 1 meter per second, then velocity became 5 meter per second, then velocity becomes 10 meter per second, velocity decreases to 8, 6, 0, then again increasing. No constant acceleration. Okay, so variable velocity, but at the same time variable acceleration too. Variable acceleration also. So here we have used what? Calculus. Okay, if x is given, in order to find velocity, dx by dt, to find acceleration, dv by dt, or d square x by dt square, or otherwise what? If we have acceleration is given, then to find velocity, integral a dt, to find x, integral v dt, likewise. Okay, so mainly this part that doesn't come much in this chapter. okay, that came in motion in one dimension, leave it. But these two things, this category and this category, we will be using. So I have told you we are going to do one approach. What is that? We will divide the motion into vertical and horizontal separately. If it is moving like this, if something is moving like this, we will resolve into vertical and horizontal separately. So if vertical has constant acceleration, we will be applying this equation in vertical motion alone. In horizontal motion, if there is no constant acceleration, no acceleration at all, we will be using this equation. Okay, so which type? Suppose there is force in vertical direction, then there will be acceleration in vertical direction. So we will have to use these equations in vertical motion. Suppose if there is no force in horizontal direction, then there will be no acceleration in horizontal direction. We will be using this equation for horizontal quantities. Okay, so whatever motion we will resolve into horizontal and vertical, then we will deal it separately. Okay, even if you have confusion now, once if we start, you will understand like what we are going to do. Anyway, right now please understand this. Okay, quick recap. Done? Clear? One more thing is, suppose if we have a velocity vector like this, if this angle is theta, then this component is going to be v cos theta and this component will be v sin theta. Okay, vector resolution. Clear? So all these things we have studied. Now with this introduction, we will get into projectile motion. Okay, so put the heading projectile motion. Projectile motion. Okay, so suppose this is a point. From this point, okay, a ball is kicked in this direction and it came here. So it starts moving with the velocity, initial velocity u. It starts moving with the initial velocity u. This angle is theta. Starts moving with the initial velocity u, and with what angle? With the angle theta. Now we will analyze this motion. It has got its maximum height, its range, time of flight, equation of trajectory, all these things we will see. Okay, now while if it is moving with the velocity u, it is going like this. What we do, as I said before, we will divide this motion into horizontal part and vertical part. How? First we will resolve this velocity vector into, okay, vertical velocity and in horizontal velocity. This is going to be u cos theta and this is going to be u sin theta. Okay, okay, so what is this u? U is initial velocity. Initial velocity at angle theta. That we have resolved into horizontal component and vertical component. Now initial horizontal velocity is now u cos theta. Initial vertical velocity is now u sin theta. Clear? This is horizontal component, this is vertical component. Okay, now generally if you throw a ball while you play or in the ground, or when someone hits the ball, someone hits 6, okay, we will analyze that same situation here. Can you just try to understand that what force is acting at this ball? if this ball is moving like this, this is one position, this is another position, this is another position, okay, so this ball is moving like this. So when the ball is moving like this, what force is acting in this ball while it is moving? While hitting it, it will experience an impulse. Someone will apply a force, but after that this force is not there. Who has hit this ball, that force will not be there. So ignore that force. Once after moving, after it starts moving, what all force are acting on this ball? We can say that there will be force of gravity towards the ground. Correct, there will be force of gravity towards the ground. Air friction will be there. Air also will be blocking this ball. Okay, so that we are ignoring. We don't consider air resistance here while we study. So what other than that, what force is there? Force of gravity is there. So when force is there, there will be an acceleration. There will be an acceleration. What is that acceleration? Acceleration due to gravity. G will be there. Clear? So vertically there will be an acceleration. Okay. Any other force is there in vertical direction? No other force in vertical direction. Okay. Now, is there any force in horizontal direction? Any force in horizontal direction? If we neglect air resistance, there is no force in horizontal direction. So we can say that AY, that is acceleration in y direction, is equal to G. Force in y direction is what is Fg. Okay. Now along horizontal direction, Fx is equal to 0. No force is there. So acceleration along x direction is also 0. Okay. So what kind of motion the ball will have along horizontal direction? Along horizontal direction, no acceleration. So along horizontal direction, it is following constant velocity motion. Okay, so throughout the motion, the horizontal component of velocity will be constant. It will not change. So this u cos theta will be same throughout. U cos theta. Here this is also u cos theta. This is also u cos theta. Okay, so throughout the motion, the horizontal component of velocity, this we have written as u cos theta is the initial horizontal velocity. This initial horizontal velocity will not change. So throughout the motion, u cos theta will be constant. Suppose if we need to find the distance till this, horizontal distance till this, how much horizontal distance the ball has covered, if someone asks, which formula we will be using? Constant velocity motion means what we will do? V is equal to S by T equation we will be using. Correct or what? We will be using V is equal to S by T. So horizontal motion is constant velocity motion. U cos theta will be constant. Right. Now vertical motion. If we consider vertical motion, there will be acceleration towards the ground. So that acceleration due to gravity is constant or it is variable. G is equal to 9.8 meter per second square. It is constant value. So we have got constant acceleration in vertical direction. So this is horizontal. In horizontal, it is constant velocity. So V is equal to S by T. And so V H horizontal is throughout the motion u cos theta. Okay, u cos theta. Now vertical, in vertical G is there. So G's value is 9.8 meter per second square. So this comes under the category of constant acceleration category. So which all equations are valid in vertical motion? V is equal to U plus AT. V square is equal to U square plus 2AS. S is equal to UT plus half AT square. These equations are valid in vertical motion. But instead of U, what we will be doing? We will have to put U sin theta, because U is common for both. For horizontal motion, we should take horizontal velocity. For vertical motion, we should take vertical velocity. So here U sin theta is vertical velocity, U cos theta is horizontal velocity. Horizontal velocity U cos theta is constant. Vertical velocity U sin theta is just initial velocity. It is going to change because acceleration due to gravity G is there. So selecting this equation, V is equal to U plus AT, V is equal to U plus AT, what we can take here? What will be the velocity, vertical velocity at this point? V is equal to U plus AT. If we consider V is equal to U is initial velocity, here U sin theta is the initial vertical component, G is in the negative direction minus GT. Okay, if time is t1 here, we can put here, if the time instant the ball reaches here is t1, then we will have to put here t1. Now what about this one? Here if the time instant is t2, what we will do? V1, this is V1, this is V2 is equal to U sin theta minus GT2, minus GT2. Right? Any confusion? Okay, note it down. Clear? Okay, fine. Now let me ask you a question. At the topmost point, what is the velocity? At the topmost point, if we throw a ball, if it reaches here, it will stop, then it comes back, if it is pakka vertical motion. In this case, what is the velocity at the topmost point? If the velocity at the topmost point is 0, if your answer is velocity at the topmost point is 0, it will stop there and it will come back, but it is not stopping, it is going, it is continuing like this. So its velocity is not 0. Now we come back to our approach. What is the horizontal velocity at the maximum height? What is the horizontal velocity, horizontal component of velocity at the maximum height? So U cos theta, U cos theta, U cos. So throughout the motion, horizontal component is not changing. So horizontal component is there, U cos theta, and it is moving also. It is moving in horizontal direction also. What is the vertical component of velocity? What is the vertical component of velocity of this ball at the maximum height? Question is, what is the vertical component of velocity at the maximum height? The answer is 0. If it is not 0, it would have gone further upward. It is not going. It stopped there, moving upward, then it started coming down. It is going like this, then it is not moving up. It is again coming down. So it is not moving up. So it doesn't have vertical component of velocity. So Vy is equal to 0. Very important. Very important. At the maximum height, no component of vertical velocity. Vertical component of velocity is 0. That is the reason it is not going up further. It stopped going up. It is there, then it is moving horizontally only, then it is coming down. No component of velocity in the upward direction. Right? Clear? Understood? Fine. What about if the ball is coming like this? If we consider a position, considering this position, all are same. If we consider this position, here what is the vertical velocity? It has vertical velocity, but in which direction? In the downward direction. So again, Applying the same concept, suppose if the time is t3, if we consider this vy3, okay, vy3. So this is vy1, this is vy2, okay, this is vy at a maximum height. So this is v3, if we consider again u sine theta minus gt, okay. So its direction is negative, here also what, suppose if the time instant is t4, if we consider this as vy4, this is going to be u sine theta minus gt4. What about here? What about this one? Now we should understand one more thing. In vertical motion, we have studied a concept called symmetry. What is symmetry? If a particle is going up, when it reaches this level, whatever be the velocity while it is going up, the same velocity will be there while it is coming down. The same level, same velocity, only the direction is different. Okay, just like this. If a ball is moving up, okay, if this is ground, at this point, if the velocity is 2 meters per second, then after going to the top, when it is returning, here also its velocity is going to be what? 2 meters per second. Direction is downward, here direction is upward. Because of that reason, at the same level, this vy1 and vy3 will be same. vy1 and vy3 will be same, only difference is negative sign. Here if we consider, this is vy2, this will be same as what? vy2. So finally, before hitting the ground, this velocity is going to be u sine theta again. Whatever be the velocity here, same velocity will have u sine theta. Okay, clear? Note it down. Okay, pause the screen and note it down. So I repeat the concept. First, the approach we should understand. Then once if we start doing problems, things will become more comfortable. Okay, now thing is, a motion in two-dimension movement, we divide that into vertical component and horizontal component. If force is there in vertical component, we will use constant acceleration equations for vertical motion. If no force is there, we will be using constant velocity equation, v is equal to s by t for horizontal motion. Okay, in the case of projectile, a ball or a particle just projected at an angle theta with the initial velocity u. So this initial velocity we resolved into u cos theta and u sin theta. Okay, there is no force in horizontal direction. So in horizontal direction we have what? Constant velocity motion. V is equal to s by t equation can be used, that here v will be constant also. So in the horizontal direction, horizontal component of velocity is u cos theta. So u cos theta, u cos theta, u cos theta, u cos theta, till the motion ends, the horizontal component of velocity will be u cos theta. Okay, in vertical direction, there will be force of gravity acting in the downward direction. Because of this force, there will be an acceleration ay, okay, which is equal to g, 9.8 meter per second square, that will be acting downwards. So because of this reason, vertical component of velocity is not constant, just like a horizontal component. Vertical component of velocity will change. So what formula can be used? These equations of kinematics can be applied here just because of the presence of constant acceleration. So if we consider like that, v is equal to u plus at, if we apply, since we are writing only vertical velocity here, we should take vertical initial velocity. Okay, when we consider vertical velocity, when we are trying to find vertical velocity. So students, in order to find vertical quantities, we will select the type of motion and we will use vertical initial velocity, vertical displacement, time is common for both, to find vertical acceleration also. In order to find horizontal quantities, what we do, we will consider horizontal initial velocity, horizontal displacement, horizontal acceleration. If horizontal acceleration is 0, v is equal to s by t is the basic equation. There we will be using u cos theta in this case. Vertical, there is acceleration, so you will be using u sin theta, and we will be using v is equal to u plus at kind of equations. Okay, so that is the overall idea. Now see, if this is a projectile motion, if we consider this as y-axis and this as x-axis, if this angle is theta and initial velocity is u, then we can say that this is u cos theta and this is u sin theta. Suppose if we consider this point, okay, what is the horizontal displacement? If this is origin, what is the horizontal displacement with respect to this point? This is point P1, say for example. What is the horizontal displacement between this point and this point? The horizontal displacement is this one, x. What is vertical displacement? Vertical displacement is this, y. This is horizontal displacement, this is vertical displacement. Okay, what is the horizontal velocity? Since there is no acceleration due to gravity in horizontal direction, this is going to be u cos theta. What is vertical velocity? This is going to be v is equal to u sin theta minus gt, u sin theta minus gt. At the topmost point, the velocity is u cos theta, vertical velocity vy will be 0. This is also what, vy. Suppose if we consider another point here, then this is what is, with respect to origin, that point, this is what is the horizontal displacement. What is the vertical displacement? This is the vertical displacement, y. Correct. Now suppose if this is the point, last point in the projectile motion, if we consider the horizontal displacement, this is what is called range. You might have seen this. Range is the complete horizontal displacement in the projectile. Complete horizontal displacement. See, this is just a horizontal displacement, this is also just a horizontal displacement, but complete horizontal displacement is called range. Alright. Now what is the vertical displacement at this point? Vertical displacement at this point is 0. Sy is 0 here. This is Sy is y. This height. Here Sy is what? This height. Here the vertical displacement Sy is nothing but maximum height. This is xx. Maximum horizontal displacement is range, maximum vertical displacement is 0, but here the maximum height is also what? Vertical displacement. Clear? So based on when the particle is here, horizontal displacement is x, vertical displacement is y. When the particle is here, horizontal displacement is this much, just we can simply measure, okay, half of range. vertical displacement is maximum height. If we take another point, horizontal displacement is this much, vertical displacement is this much. At the last point, when the ball or the stone, whatever it may be, when it touches the ground, this horizontal displacement is what is called range, and here the vertical displacement is 0. Okay, and there is another thing called, this is maximum height, maximum height. Okay, maximum height. Okay, or we can say the maximum vertical displacement possible in the projectile motion. Okay, this is what is maximum height, and this is what the maximum horizontal displacement. That is what its definition is. I am not going to give notes like that. Okay, just this is what the definition is. You can note it down. And there is something called the time of flight. Time of flight t. Time of flight t. So what is this time of flight? The time duration for which the particle is in air. Okay, time duration for which the particle is in air. That is the time taken from the projection till it reaches here. Okay, so this duration is what is time of flight. Okay, from here to here, how much time it takes, that is what is time of flight. Okay, so range is the complete horizontal displacement, complete vertical displacement is 0 once the thing reaches the ground. Total time of flight is nothing but the time duration for which the particle is in air. Okay, so time of flight, range, maximum height. These three things are important that we will see now. Clear? Note it down. Okay, right. So how to find time of flight, maximum height, range? Okay, I am erasing all this. Okay, any formula can be used. Any formula can be used. Any basic equation can be used in order to find the time of flight formula. See, suppose if we consider vertical motion. If we consider vertical motion, we are not touching horizontal part. We are considering only vertical motion. So time of flight is nothing but the time taken to reach here from this point. From this point all the way to reach here, how much time is taken, that is what is time of flight. So if I take the equation SC is equal to ut plus half at square. Okay, so this equation is applicable for vertical motion because what is there? A constant acceleration g is acting. Okay, so what is the vertical displacement? Sy initial uy into t plus half into ay into t square. When I am trying to find the vertical displacement, I should choose vertical initial velocity, I should choose vertical acceleration, everything should be vertical. Okay, so when the particle reaches here, what is the vertical displacement? 0. Vertical displacement is 0. This is equal to, what is the vertical initial velocity? U sin theta. U sin theta. How much is the time taken for this? Into capital T, time of flight. Okay, plus half into, what is the vertical acceleration? Acceleration due to gravity. Then down, towards the ground. So it is minus g into t square. I am putting t square. Okay. Okay. So now, if it comes this, that comes to this side, half gt square is equal to u sin theta into t. So this t, this square will be cancelled off. So time of flight t is equal to 2u sin theta by g. This is the formula for time of flight. Okay, note it down. Formula for time of flight. 2 into u sin theta is what? vertical initial component of velocity by g. Clear? Now suppose we have studied vertical motion in one dimensional motion also. We have studied vertical motion in one dimensional motion also, just like this kind of motion we have studied. So while we study this type of motion, that is horizontal vertical motion, the time taken to reach to the top, that is we have studied as time of ascent, which is nothing but u by g, and time taken to come down, that is time of descent, is equal to u by g. So here also time of flight is equal to ta plus td, that is nothing but 2u by g. We have studied in motion in one dimension. So here this is vertical motion. So for in vertical motion, the formula for time of flight is 2u by g. So here also we are considering only what? Vertical motion and trying to find time of flight formula. So same thing here, instead of u, in projectile motion what is coming? U sin theta is coming as the initial velocity. Here initial velocity is u. Instead of that, here the initial velocity is u sin theta. So simply in motion in one dimension, 2u by g, instead of that u, just put u sin theta, same formula comes here. Okay, clear? So this is what is time of flight. Okay. Right, now same thing here we have studied. H max is equal to what? U square by, what was H max in this thing? Just like if it is going upward, finally velocity will become 0. This height is H max and V is equal to U plus AT. So V is equal to initial velocity u, this is 0 at the maximum height, minus gt. Okay, minus gt. Suppose if we take V square is equal to u square plus 2as. So from here only we got what? Time of ascent is equal to u by g in motion in one dimension. Here this is, if we consider this as h max, and here the final velocity is 0, u square minus 2g h max. This we have studied in motion in two dimension. So this comes this side. Finally we got a formula like u square by 2g. U square by 2g. I have told you when we discussed motion in one dimension, I have told you you should remember this formula. Now here maximum height in one dimensional vertical motion, the formula was u square by 2g. U square by 2g. So here what we should do? Instead of that u square, here vertical velocity is u sin theta. Just put there. H max is equal to u square sin square theta by 2g. This is the formula for maximum height. This is not direct derivation. Just I have applied this equation, this initial velocity, vertical velocity, in the formula of vertical motion which we have studied in one dimensional motion. So in the same formula I just put the initial velocity just here. I just substituted here. We have studied this formula in motion in one dimension. I just substituted the initial vertical velocity here. That is the only change I have done. We got the same formula. Okay, now how the real formula we can derive? See, SC is equal to ut plus half at square. Now this vertical displacement, this is what we are trying to find, that is H max. This is initial vertical velocity u sin theta. This time is what? Half of time of flight. If this full is time t, then to reach this place the time of flight half the time will be half of time of flight. So here I can put here t by 2 plus half into minus g into t square, that is t by 2 the whole square. Correct or what? H max, just I am putting in this basic equation. This is the vertical displacement when the particle reach here. This is horizontal displacement, this is vertical displacement. I just put H max as displacement, u is the initial vertical velocity. The time taken will be half of time of flight. Till to reach here it is full time of flight, to reach here it is t by 2. I just substituted all those things. Now already we have found what is time of flight. Time of flight is equal to 2u sine theta by g, that we will substitute here. So H max is equal to, okay, first what we will do, use sine theta into t by 2 minus half into g into t square by 4. Fine. So we will substitute for the t by for what, for time of flight. So right, so H max is equal to u sine theta into t plus half into minus g into t by 2 the whole square. Right, so we will substitute u sine theta into 2u sine theta by g minus half into g into 4u square sine square theta divided by g square. Okay, g square, and this 4 also will be here. Okay, so this g will be cancelled, 4 will be cancelled off. So finally what we are getting here, 2u square sine square theta by g minus half into u square sine square theta by g. Okay, so here I missed a 2 here, so 2 will come here, 2 will come here also. Okay, I missed this 2. Time taken is only half of time of flight, right? So this 2 also will be cancelled. So this is full, this is half, 1 minus 1 by 2 like. So what will happen, we will be getting H max is equal to what, u square sine square theta divided by 2g. So same result only we got now. H max is equal to u square by 2g was in vertical motion. Instead of u we put just u square sine square theta divided by 2g. Same formula we are getting. Okay, so things are easy. Since we are finding vertical displacement, we used s is equal to ut plus half at square. So s is nothing but H max. Time taken is nothing but half of time of flight, that also we substituted. Initial velocity is nothing but vertical initial velocity, we will be getting the formula. So instead of doing all this, if we u square by 2g in this vertical motion, in the same formula, if we put that initial vertical velocity here, we will be getting the same result. Okay, so this is H max. Okay, maximum height. Now what is also there, the range is also there, we need to find, note it down. So this is what is range. Range is what? Horizontal displacement. Range is horizontal displacement. Which formula we will be using? V is equal to s by t, because in horizontal direction no acceleration and the velocity will be uniform also. So u cos theta, this is the horizontal component of velocity. This is not going to change throughout till it reaches here. Okay, u cos theta is the velocity, and this s is nothing but horizontal displacement, full horizontal displacement. The time taken will be what? Time of flight. So r is equal to u cos theta into time of flight is what? 2u sin theta by g. So what is range? Range is equal to 2, then u square into 2 sin theta cos theta divided by g. This is also correct. Okay, and 2 sin theta cos theta is what? Sin 2 theta. So that also we can write as r is equal to u square sin 2 theta divided by g. So this is range. Clear? So we got time of flight, maximum height and range. Okay, please note it down. Okay, so what we have done for vertical motion, since acceleration due to gravity, constant acceleration due to gravity is acting towards the ground, we have considered equations of kinematics where acceleration is there. V is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as. That only we have used. For horizontal thing, since there is no acceleration, no force in horizontal direction, v is equal to s by t. Simple formula we have used. Okay, and using that you can have your own method to derive this. Only thing is correct substitution must be there. Okay, so that we will be getting the all the formulas, right? So now we will summarize. We will summarize. One thing is time of flight, range, maximum height. So I am just telling you a story or just a code to remember the formulas. Just remember like a time of flight, range, maximum height. Tennis racket at home. Okay, tennis racket at home. Time of flight, range, maximum height. Okay, so 4 friends were there. Okay, one friend is u, another friend is u, one friend is 2, another friend is u, third friend is sin theta, another friend is g. Okay, so 2u sin theta divided by g. Okay, so among for all the friends, 2 is the dearest one. For everyone there are some personalities like that, right? Everyone want that person as the friend, someone who is very sincere, very lovable person. So 2 is very lovable, very sincere. So Mr. U, Mr. sin theta, Mr. G, all of them need this 2. Okay, now what 2 will do? 2 will convince. Now 2 is near u, so u is happy that 2 is near me. Now 2 will convince you that I am with you, just I will do some work and come. Okay, so when 2 moves away, that u will be thinking. So 2 is not really with you now, but actually he is thinking. Okay, in his mind, who is there? 2 is there. So now when it comes here, 2 is actually not there, but in u's head, who is there? 2 is there. Now 2 is with whom? With the sin theta. Okay, now he is spending time with the sin theta. Now again sin theta is happy. Okay, 2, my dear friend, is with me. Now again what 2 will do? Okay, you be here. Okay, I am with you. My most beloved friend is you only. Just I will go to another for some work and I will come back. then what sine theta will do? He will also think about 2 once he leaves. So when it comes here, u is also thinking about 2. Sine also here, this is head, na? Head means top here. So sine is also thinking about 2, but actually 2 is now spending with the g. So this 2 is managing all other 3 fronts. Okay, so 2u sine theta by g, 10 is racket at home, remember in this order, 2u sine theta by g. Now while 2 is moving to sine theta, you will be thinking about this 2. So now 2 is with the sine theta. Now when 2 is moving to g, u as well as sine, both are thinking about whom? About 2. So on the head 2 will be there. So remember like this. Okay, now that one. Another thing is, for the projectile, this full displacement Sx is nothing but range. Sy here it is 0. This maximum height Sy is nothing but h max. Here if we are projecting with the velocity u, horizontal component is u cos theta, vertical initial component will be u sin theta. But every point u cos theta will be same. Every point u cos theta will be same. Every point u cos theta will be same. Okay, u cos theta will be same. U sin theta, yes, it will change. Vy1 is equal to u sin theta minus gt1. At maximum height, Vy is equal to 0. If it is not 0, it will go further up. Here, same level, same value will come, but in the reverse direction. So minus Vy is equal to what? U sin theta minus gt. Okay, so whatever be the time here, that will come here. So here at the last point, this is same as u sin theta, just because of the symmetry we have studied. Okay, so hope you understood the concept. Okay, so in the next class we will do some problems. Okay, and we will build the topic further. So with the practice, this handling motion in a plane in as 2 one-dimensional motion. Okay, just vertical, horizontal, vertical, horizontal, vertical, horizontal. Separately, how to deal will become a practice. Okay. Okay, so I am winding up the session. This is just an introduction. We are putting the basics. In the from next class onwards, we will start doing problems occur. Okay, fine. Goodbye, students.